Hi, in this video I'm going to redo the test for the 3DMakerPro Eagle because they have launched a new software, Array Studio version 1.0.8, and in this version it has a new feature where I can manually close the loop. So if I scan the larger area like this and it has a drifting alert, I can manually align the starting point and the end point, and this software should correct all the drifting alert. Now I'm riding with a speed about 10 kilometers per hour, and I'm trying to hold the scanner parallel to the horizontal plane as much as possible. 3DMakerPro didn't give me a handlebar mount. If I ride on the EUC, I will have a free hand to hold it. My other LiDAR scanner, it comes with a backpack and a RTK unit. So if I want to do a large area scanning, I will use e-scooter. So this loop is about 400 meters, and I believe that it's going to drift, so I can test the manual closed loop function. I will try to stop closer to the starting point as much as possible. I believe it's about here. It's 2 minutes, and I think it's work. This is a new update firmware, version 1.0.7. SSD drive to export data. Okay, this is a new version of the Array Studio, version 1.0.8. I noticed some change with the basic data. I found that the new version is process data much quicker, and it gave much better results. I do this small loop test. I place the scanner over a marking point on the floor. I close the loop. They have a new function called manual close loop. You can make a close inspection of the starting and the end point. For this function to work, you need to place your scanner on the floor with the marking, and when you finish the scan, return to the starting point and place your scanner exactly at the same point when you start, facing it in the same direction. And when you inspect your trajectory and you found that the red and the blue trajectory match perfectly like this, it means that your scan has no drifting alert. This sample is only 50-60 meters of the loop, so it has no drifting alert. So after point cloud filtering and thinning, I found that the result is better than the previous version. The noise from the point cloud is much lesser. The noise level is very low. This is a very clean scan. And for the color scanning, I don't see any improvement. It's the same. The noise level is still high. So let's try basic LiDAR, point cloud thinning. Here's the outdoor. I can confirm that the point cloud processing is much quicker than before. Okay, here's the result. Okay, it looks normal from the top, but if I look at the starting and the end point, the position of the load is drift. I think it drifts about 2 meters on the elevation. So I'm going to click on the point cloud here. Click on this button. Okay, now you can see that the starting and the end point here is spacing very far away. You can see here the red is the starting point and the blue is the end point, and it's not matched. I'm going to double click my starting point, and this will be my end point. Click on next. Okay, so you can see that there are discrepancy between the red and the green color. So I'm going to move the blue axis up here. Okay, I'm going to move the X and Y axis. You can use your mouse to move it. And for the rotational, I don't think I need to adjust it. So I hope you can see this, but I can't. So just match the red and the green together. Okay, then I should click on add. I should click on apply. So I need to wait. Closed loop part application successful. That's quick. Close, right? Okay, let me turn on this. Okay, this is a fixed one. Let's see if it fixed. Okay, you can clearly see here that this canopy has a double layer, and it is about 2 meters away. But when I fix it with the manual closed loop, now it's gone. See that? Now the starting and the end point is aligned. Only issue that I don't know how to export this. Okay, at this point I found that if I export as the LAS file, it will crash the software. But if I export it as a PCD, it will not crash. Now it's come up here. Let's see. Yeah, the load pavement is aligned, so it works. The detail of the point cloud is not much comparing with walking. I would say walking will give you more information. Okay, now you can use your Eagle for scanning a very large loop, and when it drifts you can just align it manually, and then you have to export it as a PCD format. Here, let me measure the length of the loop. Click here. It's not accumulate dimension. You need to add up the numbers yourself. Okay, I add up the number is 400 meters. Okay, let's check the result from the color point cloud. I can see that it drifts the same way as the non-color one, and the data that it has been captured is a lot less. So I think you should be walking if you want to scan with the color. Okay, let's align it. This would be a starting point. This would be end point. Click on next on the Z-axis. So I need to move it up here. I can move the plane. Just move it using my mouse. Okay, this should be close enough. Click on apply. Yeah, it fixed. You can see this. The load is now in the same level. It can see a lot more data on the starting point because I spend longer time when I mounting on the EUC. So at this point I write too fast and the data capture is not much. I like using the color point cloud. I use it for presenting my customer when I do conceptual design. It's faster, so I don't have to model the environment. So I just scan it and I can design the new object over the scan data. It's quick, and when I present it to the customer, they quite enjoy it because look more realistic. Thanks you guys for watching. See you in the next video.